So let's begin with some technicalities. When we use our interval notation and we use a parenthesis like this or like this, it's referring to something on the graph that's open, circled. This means that the relation is not defined at this value. In other words, it means I didn't actually hit that number. It's an open circle. Now, the same thing goes true with when our graph is going towards infinity, right? Positive or negative infinity. Well, we don't actually hit quote unquote infinity. And so the idea that we're approaching infinity, we're going to go ahead and end up using parentheses for that. We will end up using brackets when it is defined. So when I do have a closed circle or when I actually do have an actual value at that point. So let's look at the domain and range. Remember, domain is the x value, so that means I'm looking at the left and right values for this graph. Here is the domain of this graph, and here's why. If we're going to the left, how far left do we go? Well, we go as far left as -2. However, it's an open circle, which means we never actually hit -2. We just get very, very close, but we never hit it. And so that's why I have parentheses for that. How far right do I go? Well, it looks like I go as far right as this value right here, which is a 2. It is closed circle, so that's why I have the bracket.
You're brilliant. You're handsome.
If it helps, consider doing the coordinates for these points, right? So if I look at my x values, I have this is a -2, and this is a +2. And the domain is the x value. So if I take those two x values from these points, this is the far left one, this is the far right one. This defines my domain for this function. However, I have the open parenthesis here because it's open circled, and I have the bracket here because it's closed circle.
You're welcome.
In the same manner, if we consider the range is the y value. So if I look at these y values, and my lowest one is 0, however, it's open circle, so I never hit that 0, and that's why I'm using parenthesis. My y value, my highest y value here is about a 7.5, and it does actually hit it because it's a closed circle. So the range is going to be 0 to 7.5. Now, this includes everything in between. So notice these 2 points are connected. If I happen to just have 2 separate points and nothing in between, then, for example, it would have an and in between. So if all I had was just this point and nothing else in between, the range, for example, would be 0 and 7.5. But we have things in between.
Great job, everybody!
So to help us out with this second graph, we do have this point right here. It is closed circle. It's -7, -0.5. This is just a coordinate that you've learned since elementary and middle school. However, this is not a point. This is an arrow. And so if it helps, ask yourself, what would this arrow do? It's going this direction forever, right? So notice it's going down forever, but it's also going to the right forever. Okay, so keep that in mind. Let's start with the domain. The domain is how far left and how far right does it go? Well, how far left does it go? We know it's -7. And this time I'm going to use a bracket because it's closed circle. I do have stuff in between here and wherever else it goes. But where does it go? Where does it end?
Most impressive.
How far right does it go? Well, if you have no screen, you could just keep drawing this line forever and ever and ever. We don't know exactly how far it will go. So based on this graph right now, it looks like it's going to go to the right forever. So for now, we'll go ahead and just put a infinity, or a positive infinity if you want. Now, because we're using the symbol for infinity, I have to go ahead and use parentheses for that. Remember, domain is how far left does it go, and how far right does it go. The range is pretty interesting. So remember, how far up does this graph go, and how far down does this graph go? Well, how far up does it go? This time, this point doesn't really help us out, because this is not the highest point. Actually, this right here is the highest point. And what y value is that? Well, that's about a 1, right? So how far up did I go? I went 1 up. So may I propose to you that this is a 1.
You're brilliant. You're handsome. You're rich.
And then how far down does it go? Well, it goes down forever, so that's a negative infinity.
You're welcome.
Now, there is a slight problem with what we just wrote. I'm hoping it makes sense, but it's kind of in the wrong order. Notice how for the domain, for example, we went from the smaller value to the larger value, right? From negative to positive. And so we're correct about the range, but the way we've written this is not necessarily the best way to write it. The better way to write it would be to put the negative value first and then the positive value over here. So almost like a number line, right? From smaller to larger. So we would say the range is from negative infinity to positive 1. Remember, the range is how far up and how far down it goes. So the vertical line test is an actual test that we draw on a graph, okay, of a relation that purports to be a function. And so if it passes the test, yes, it's a function. If it doesn't pass the test, it is not a function. So there are many things in math that are not functions, but there are also others that are functions. So how does this test work? It's simple. You just draw a line straight up and down. Anywhere you can. And if you hit 2 spots, you win.
You
Check
win.
it. So if I draw this line like this, you notice that I hit this in 2 spots. If I hit it in 2 spots, the answer is no. This is not a function.
You lose.
But you're probably asking, Mr. Over, what if I hit this at only 1 spot? Does that make it a function? The way the line test works is if you can hit it twice in any 1 spot, then it's not a function. So just because you can only hit it once doesn't make it a function. The test is if you hit it more than once, it's not a function. So here is part B. What if I put a line through here? Well, I only hit once here. What about here? Well, I only hit it once here. Here, only once. What about that, Mr. Over? No, no, no. It's a vertical line test. You only draw it up and down.
You lose.
You don't draw it left or right. You don't draw it diagonally. So the answer to this question is B a function? Yes, because it passed the test. So again, we're just drawing a line up and down. Graph C, I just drew a bunch of lines up and down, and no matter what, they only hit once. That means graph C is a function. So of all 3 of these that we just did, graph A is the only one that is not a function.
Great job, everybody.
Problem 6 is interesting and unique. It's called a step function, and it's pretty much, you graph this step by step. So check it. I'm going to graph 1 if x is less than 1.
Most impressive.
And this 1 could go on forever until I hit this part. Now, it's got to be less than 1, so I'm going to draw an open circle because it's less than 1. How about it's going to be 3 in between 1 and 4. So that includes 1 because it has this symbol. But then it goes less than 4, so I go all the way here and put an open circle.
You're brilliant. You're handsome. You're rich.
And then if it's 4 or bigger, it goes on forever as a 5. And if you kind of look at it, it kind of, don't connect them, but you can kind of see like, it looks like steps, right? And there's more complicated ones, but this is a pretty basic step function. So here's a graph of it. What about the domain? The domain is everything left and right, x-axis. So how far left does this, the blue, green, and orange are all one graph. This is all the same function. It's called a step function, or a piecewise function in this case. Piecewise function is a general. This is called a step function, a special case. So we look at this. How far left does it go? Well, it goes this way forever, right? So that means negative infinity. And to the right, it goes on forever. So that's positive infinity. And we use in parentheses because we don't use brackets with infinities. The range. Well, this is kind of interesting. So the range kind of jumps around. It starts at 1.
Most impressive.
And it does include it. And then it goes to 3. There's no values in between here and here. Okay? So because there's nothing in between, I'm going to use an and. And does it stop at 3? No, well, actually it goes to 5, right? So we shouldn't put 3. We should probably put 5. Well, we need to put 3 and 5 because it stepped around. and it does include 5. So a very strange range, right? Because these are the y values. It hits 1, it hits 3, and hits 5, and that's it. For your summary, is it always true that if a function passes the vertical line test, that its inverse, right? Its inverse will also pass the vertical line test. Give examples. And you might want to look at graph A in problem 5, because that looks familiar, right? That should look like what we did in problem 1. Give it a look.
Great job, everybody.